Hello, hello, hello! David Snowpack here from Snowpack Games. How is everybody doing? Please say hello in the chat if you're watching. I don't know who's watching unless you say something. Otherwise, I just get a little number. I have a little eyeball that has an 8 by it. So whoever you 8 people are, please say hi. Let me know, what you're working on, what you're doing in game dev, and what your interest is in network games with Godot. Maybe that'll help me decide some things to sneak in for you into our stream today. We are going to be working on one of... Hey, Andy K! We're going to be working on my game Retro Tank Party today, which you can get from itch or Steam. Hey, Ross, good morning. And we usually like to start our streams with a little bit of playtesting the game, although I forgot to start Steam before we got in here. Maybe I'll play the web version. I never play the web version. That'll be a good test to see if the web version still works. So, to get to the web version of Retro Tank Party, there is a link below. Here, I guess this is the right way to point. That bit.ly link, which... here, let me try to type it. I have it so tiny here. I have like a little tiny screen. Okay, bit.ly RTP devel. And I guess if you're one of the people who usually does playtests and usually plays the Steam version and you want to play along, I don't think this is compatible with the Steam version, the one that's on the web, because it's built from a different git commit hash. So let me just quick get up a match ID. Anyone in stream who wants to jump in and play? Hey, Damon, I remember you from the last stream. Here is a match ID for the game. So check out the bit.ly link. Join this match ID. We'll play the game a little bit. We are very close to having a new release of the game, the 1.1 release, coming to Steam and itch. I'm probably going to release it tomorrow or Sunday, something like that, which has a whole bunch of new content. There is 1 new weapon, 3 new abilities. There was going to be a new game mode, but I guess I'm gonna pull that and bring it out for the next release probably, because there are some gameplay, some game design issues that I want to work on a little bit before putting it out there. As you guys are getting connected, anyone who wants to join, I hope someone wants to join. This would be really anticlimactic if no one joins. Elliot is just lurking. You're not going to play today, Elliot? So last week we were working on implementing rollback network synchronization, but in a demo project, which I've worked on a bunch since then. Where we ended last stream is it wasn't actually working. Like it would start up and try to move around, and things weren't happening. But I've gotten it fully working, implemented a whole bunch of new features, which I'm going to show you guys before we really get started in hacking on this. And then I want to take what we made for that demo and then move it over to Retro Tank Party. Let me go see if anyone's gotten in. No one's getting in? For real? All right. All right. If no one wants to jump in, I can show like the practice mode. Here, I'll make... Oop, someone came in. I almost missed it. Hey, Tanks a lot! It's been a while since I've seen you, Tanks a lot. See if anyone else gets in. I guess while we're waiting, we'll give people another minute or two. Ooh, Ross is having trouble with copying and pasting the match ID. Hey, Ricardo, how's it going? Ross, are you on Firefox? There is an issue. Oh, Ross is getting in. Hey, there's an issue with paste in Firefox for some reason. All right, we'll give Andy K can't connect. Oh, can't create account. What's the message you're getting, Andy K? I guess I haven't tested creating an account in the web version in a while. I hope it's not busted. But let me know. Yeah, so there is some issue. I think it's actually a Godot issue, or maybe a Firefox issue, because Firefox has like more privacy stuff than the other browsers. Oh, hey, okay, cool. I can connect Tanks a lot with a real life name. That's awesome. Yeah, so for whatever reason, HTML5 games in Godot do not have like paste in Firefox. If you switch to Chrome, paste should work. I've been meaning for literal years at this point to implement like a shortener to make these UUIDs smaller. All right, we have a fourth. We have Andy K in here. All right. Let's play. Okay, so yeah, let's test a deathmatch because that's the mode of the game that has had the most changes. Let's do a team mode. I don't know if we've done a team mode on stream before. This is gonna be cool. All right, so it looks like me and Ross versus Tanksalot and Andy K. Let's do this. I like the desert. Lots of power-ups in the desert. Very chaotic. Okay. Well, of course I have the music turned off. Let me get a little bit of that on there. Ooh, don't shoot me! Oh, that was my teammate anyway. Going down, Tanksalot. Oh no! Andy K's got the spread! Let's see if I can back up Ross here. Oh, we got him! Woo! Teamwork. Ooh, I got a railgun. See Ross boosting around. Yeah, there's definitely like a lower frame rate going on in the web version. I don't think it was this, there was this big of a difference the last time that I played the web version. Of course, the game has gotten a lot more advanced. Ah! Andy K's coming at me with the spread. I got the railgun for a couple more seconds. Okay, my railguns ran out. Ooh, didn't corner me, which is good. Ooh, Ross, don't hit me. Oh, I'm zapping out of here. Woo! That's like a perfectly timed zap. Oh no! Now Andy K's got the railgun. Oh, thanks a lot. We're doing pretty good, Ross. 2-0 here. Alright, I got the spread and some zaps. Oh, I should have zapped. I should have zapped. I was cutting it too close. Thought I could get another kill in before I had to zap out of there. Oops. Ooh, did I kill you, Ross? I'm so sorry. I didn't mean to kill you. I didn't actually watch the score, but we should have lost a point for when... Ooh, I'm boosting out of here. For when I killed Ross. Hopefully the score was counted correctly. I very recently, like a week ago, rewrote all of the scoring in deathmatch mode because there were a bunch of bugs in it. No! Boost! Get a little more distance. Okay, whoa! Ah! Don't celebrate too quick. Whoop! Who is that? I can't even tell. Okay, I gotta remember what color Ross is. Oh, jeez. See what power-ups I can get. Health's okay. Eep! More health is okay. I hear someone zapping. Ooh, someone was invisible. This is a good match. Very chaotic. Lots of stuff happening, and we're winning, which I guess probably biases me a little bit. Ooh, Andy's getting away from me. Two can play that game. Oh, boost! Oh, jeez. Whew. I wasn't sure I was actually gonna succeed there. Alright, I got a zap. Get a little health. How much time do we have left? 1:30. I don't think they're coming back, but ooh, maybe the next round. Woo. Ross just went invisible. Oh, who's gonna take that zap? I should have just taken it because I had full zap. It would have made no difference. I don't know why I left it there. That was a weird call. Ah, zap out of here! I love zap. Zap is up, and of course I took invisible. I guess I'll use it though. Zap is my favorite ability power-up. Alright, Andy, I'm sneaking up on you. You don't even know I'm here. You don't even know. Oh, two invisible people fighting. You know, it'd be kind of cool is if the invisible people could see each other. Alright. My health ain't great, but I got my zap. That was about as many hits as I thought I could get before that turned. Ooh! Whoa, jeez! I'm out of here. Oh, I see that power-up box over there. I'm going for it. See if I can get some health or a better... tracers are pretty good. Woo! Oh, I don't want to shoot Ross. Haha! Zap a little bit here. We destroyed Ross. It's probably not fair because you be playtesting with me all the time. Let's do a battle royale. Let's do only 3 points to win, so it doesn't last too long, and we'll go no teams. Every tank for themselves, and then we'll get to hacking. We'll do one last round, and then we'll get to hacking on the game. Oh, but it locked up. Oh no, here we go. Momentary foible. I'm just gonna write that up to HTML5 being slow. There's a very different strategy when you're playing Battle Royale mode, because in Deathmatch you want to get in there and like finish people off, so there's a lot of risk taking, whereas in Battle Royale mode it really pays to kind of stay out of the fray. If everyone else kills each other, then you don't have to do it. So I play, whoa, way more conservatively! Yeah, let Ross kill him. Oh no! Woo! Oh no! Not tracers. Tracers are my favorite weapon power-up. Oh, what do we got here, Ross? You got those tracers forever, too, because weapons don't time out in Battle Royale mode. Ah! Ooh, I need that box. Oh, Tanks-a-Lot is still... Oh, Tanks-a-Lot is, like, frozen. I wonder what happened there. Ricardo, did you get disconnected? Your tank is stuck there and invincible, which is never a good sign. Well, we found a bug. Playtesting is successful when you find a bug. I would love to hear what this looks like from your end, though, Ricardo. Did you like get knocked out? Did your game freeze? Do you think you're still playing, but we just see you stuck? I'd love to know. Oops, not return to match. Let's exit. Yeah. I would be curious to know if, like, you came back to life. Like, if we started a new one and then your tank was working. So let's just try that, and then we'll quit. We won't, like, for real play, because I want to actually get to doing some hacking here. Let's just, well, yeah. So, Maze, I'll see you right away. I'll see if you start. So let's find Ricardo's tank. Or if it's even going to let us start. Yeah. Maybe it won't. Unable to change scene. So that happens when... So the way that scene changing works is it sends a message to all of the clients to say, hey, change scene to this. And waits for all of them to acknowledge it, to say, I've changed and I've acknowledged. And it appears as one person's client wasn't able to acknowledge, which I would guess that's probably Sir Tanks-a-Lot, Ricardo. Because, yeah, he had some kind of problem there. Thanks, Andy K. I'm glad you like it. I'm glad you like it. The version that's currently available on itch and Steam does not have the railgun or any of the ability power-ups, that being Invisible Boost and Zap, but they are coming soon in just a matter of days. So I'm looking forward to finally getting that out. But today, We are going to be talking about network synchronization. We went from shooting each other in tanks to something that sounds really boring like network synchronization. And for people who weren't here at the last stream or don't already know what this is, I'm going to try and give a really quick explanation. I'm going to be starting from the same drawing that I made on the last stream, and hopefully my explanation will be much better. I felt like I kind of was just wandering around in circles. I think if we keep doing streams on this, I'm going to make like a 4-slide presentation so I can present it in a much more orderly way. Anyway, so network synchronization at a high level, that's making it so that each player, as much as is possible, is seeing the same things as the other players. So that, you shoot someone on your screen, you see the bullet hit, it counts as a hit. Games will be out of sync when one of the players, or I guess all of the players, are seeing something that's different enough that you'll shoot at a player, register a hit, and it doesn't count. Or you'll shoot where the player isn't, miss, and have it count as a hit. And no game is ever perfectly synchronized. The goal is to get it close enough that the game feels fair and feels fun. Right now, Retro Tank Party is using a very naive form of network synchronization, and we are going to be attempting to convert it to a much more sophisticated form of network synchronization, that being rollback or rollback and prediction. And I will attempt to explain what that is. So here, imagine we have 2 players in a game, player 1, player 2. They're each going to start rendering the game like 1 frame at a time, like all games are done a frame at a time. And there is a 2-frame lag between the two machines. So the game starts, player 1 is immediately pressing to the right, and they're holding right through these first 3 frames. Player 2, the game starts, for the first 3 frames, they're holding left. But with the 2-frame lag, player 2's left doesn't arrive until player 1's first frame. So the naive version of synchronization here, which is basically what Retro Tank Party is doing, is you just say, okay, now I know you're pressing left. So frame 3 is I'm pressing right, you're pressing left, and we just kind of ignore the fact that player 1 is seeing player 2's movements from 2 frames ago. We're seeing player 2 in the past. There's a whole bunch of solutions to this problem, all with their own set of trade-offs. One is having an input delay, which is actually used in almost all forms of network synchronization. So it's not just like a delay or, it's usually delay and something. But with a delay, you could say, we are going to gather player 1's inputs, but we're not going to act on them until 2 frames later. So then in that case, frame 1, we would collect the pressing right on frame 2, but we wouldn't actually start moving right until frame 3. And then that way, we would have the inputs from player 1's frame 1 line up with player 2's frame 1 because of this 2-frame delay. And if the delay is always exactly 2 frames, that could totally work. That would be really close to having the same experience on all sides. But the frame delay isn't usually totally static, and there are other problems that can come into the equation too. So the strategy that we're actually going to be looking at today, that we're going to be working on, works like this. We would be going frame 1, 2, 3. Player 2 would send us their frame 1, and when we got it, we would say, okay, we're going to inject that into the input back in time on frame 1. We're going to roll back the game state to frame 1, and then we are going to roll it back forward to frame 3. So in this scenario, player 1 would see player 2 not move at all in its first frame, see him not move at all in frame 2, but then on frame 3 would essentially see them move. Well, okay, rewind. So they would see frame 1, they would not see them move at all. Frame 2, they'd not see them move at all because we don't know what their input is. But then when this frame 3 comes along, we take this frame 1 input, inject it here, and then we roll back forward predicting what their inputs would be for frame 2 and 3, because we still don't know, but we can guess. An input prediction sounds really hard. Like, how am I going to guess what the other player could possibly be doing? Is that with some crazy AI? No. You just assume that whatever they were doing on the previous frame, they're probably still doing. And you can have little adjustments to that, like specific to your game. Like maybe you know that a particular button is associated with a move that has a cooldown. So you can say like, well, if they're pressing it last frame, they are not pressing it this frame because like we know we can't do anything with that on the second frame, or different little things. But it usually doesn't get very sophisticated. So we would roll back forward to frame 3 saying, okay, we still don't know what they had for frame 2, but we'll predict they're still pressing left. And we don't know what they're doing for frame 3 because we haven't gotten that input, but we're going to again assume that they're pressing left. So then when we get to frame 3, just kind of out of coincidence, but this is a very common coincidence, we are seeing the inputs exactly as they are in real life. We are seeing, on frame 3, player 1 is pressing right. On frame 3, player 2 is pressing left because these predictions were accurate. If they weren't accurate, if they had actually switched to right or whatever, they wouldn't line up. But given that these ticks go by so quickly, this game runs at 60 frames a second, so each tick is 16 milliseconds long. If you are pressing a button 32 milliseconds later, you're probably still pressing the button. So the odds of this prediction being correct are pretty high. Not always correct. If they're incorrect, that would just get corrected later when we roll back again. So if, let's pretend this isn't left, but it's right. So then when we get to frame 5, this message arrives over here, and we say, oh, it actually should have been a right over here. So then we would roll back the state of the game to frame 3, get rid of this left, inject a right, and then, of course, predict forward again to frame 5. And these rolling back and rolling forward, the player doesn't see the actual rolling back and the rolling forward. They just see the result. So, here, when we did the first part of this, the going from frame 1 to frame 3, the player 1 would have seen player 2 not moving at all, not moving at all. And then here, when we finally got the left input and went back and corrected all of these, we wouldn't see them move like 1 frame's worth to the left. We'd see them move 3 frames worth to the left because there were 3 lefts that we're counting here. So once the corrections come in, there can be a little bit of a jump. You'll see the player suddenly, we thought they were going left, but oh no, they're going right. So long as the amount that you're rolling back is small enough, these corrections will also be very small. But when you see the player jump, that's rubber banding. That's what that is. So last stream, hopefully this makes sense, actually. I should pause for a moment. Did my explanation make any sense? I feel like it was better this time, but let me know if anybody has any questions about how this works. This rollback and prediction network synchronization method is super popular in fighting games. There's a library called GGPO, a C library that has been used in fighting games and in other games. We are not using that library for a couple of reasons. One of the reasons is GGPO implements its own networking. Like, it actually communicates over the sockets itself, and we don't want it to do that because this game networks over WebRTC. We want to be able to control the networking. But also, we're doing this in Godot. We want it to feel very Godot-ish. So we're doing our own thing. But yeah, any questions, let me know. No one's saying nothing, so I'm assuming we're good. Last week on stream, we were playing with this demo, which I'll just show really quickly. This is a demo that's associated with my Nakama WebRTC asset for Godot in the Godot asset library. Did I type that right? Awesome. And it's not a fun game. It exists to be a simple game. Of course, using lots of little Godot faces is all Godot demos do. And hang on. Let me change my keyboard really quick. All right. So you move around, you can press the space bar, and it does this little attack. You go over, attack this guy. Snowpick wins the round. And then we hit ready, and it should reset. So this very simple game. I think this is actually the rollback branch. Yeah, it totally is. So this is the version with rollback implemented in it. Last week, I did not have it working. But you can see this is very tiny. Actually, let me show it not here, because that's going to print all these weird debug messages. Let me show it in the Godot window. Now I have to stare at my fingers while I type Dvorak. Okay. Aaron, can I expand the size of just this window? No, it actually doesn't do anything. Well, at some point I'll look to see if there's project settings that can make this font a little bigger. I hope you guys can see that over the stream. So it's logging the round trip time between the clients, this local and remote lag. That is about how many frames the client is predicting for us and how many frames we're predicting for the client. Since this is running on the same machine, just 1 frame, which is why it looks perfect, right? Because there's an input delay of 2 frames, and if there's only a prediction of 1 frame, that means we're getting all of the input before we're rendering any frames. And the advantage here is used to calculate if one of the clients is getting far enough behind, we'll actually start skipping frames to allow that client to catch up, such that to the best of our ability, like all of the clients in this game will have their ticks synchronized in like real world time. Not perfectly, of course, but as close as we are able to, which is nice. Like this synchronization technique just feels more stable than what I'm currently doing, where one client could get way ahead or way behind, and we don't do anything about that. We just take the inputs and run with them. All right. Andy K says, so player input prediction can also be used for validation and replay, I assume. Can this be used in combination with transform rigid body forces synchronization? So, rigid bodies. There is, I think, an issue with this technique and Godot physics. I haven't dug deep enough to see what that issue is and see if we can work around it. So I think as it is right now, rigid bodies with the Godot physics engine will just not work, or at least be inaccurate. So one player might see the rigid body go this way, and one player might see it go the other way. I believe that it's possible to fix this. It may involve hacking Godot, like making some changes to Godot and recompiling it. And I'm hoping that in a couple of weeks, as I get deeper into this and really get a handle on that problem and can recreate it, that we'll start working on that on stream as well. But anyway, so validation and replay. So like replay, you could totally use it for like showing like an instant replay at the end of the match or something, because you are keeping the state for every frame. You have a state buffer. I have it currently for this game set up to be 20 frames, but you can have it whatever you want to be. And so it's saving, the game state of the game for 20 frames, and anytime it can roll back to any of those states. Validation, the code right now has like this optional validation mode where the peers are sending their game state to the host, not to like do anything with in the game. Like we're only sending the inputs between the peers in order to like move them and take actions in the game. But the non-host peers are sending their state to the host, so the host can compare the state that they have with the state that it has, just for debugging purposes. So it can say like really definitively, wow, on frame 15, you have something totally different than what I have, which lets me know that I screwed something up somewhere. And I need to figure out how to make whatever was happening when things got screwed up more deterministic. One of the challenges in this network synchronization scheme is you need to be sure or have some kind of workaround for when things get out of sync to say if if on 2 computers the exact same inputs are input, the exact same thing will happen. If it's not deterministic, if sometimes a different thing might happen, like you're going to get out of sync and you're going to have these problems. So I think in the final game or in like a live game, you might send the state back to the host. Not every frame, but every so many frames. So the host can say, are we in sync? Are we out of sync? And if you're out of sync, just bail, maybe. Or if you can't quite get things totally deterministic, you could also have the host periodically send the state to the peers and have them resync on the state from the host, which, given all of the stuff that's in place, would work. Like you could say, okay, here's the state from frame 10. And even though the inputs haven't changed, let's just all roll back to frame 10, inject this new state, and then roll forward so that we can resynchronize ourselves. So anyway, where was I? We have this demo. And oh, I want to show you this too. I added this like overlay, which is super boring with only one peer. But also, yeah, it tells you some of the same information we were looking at before, and it will tell you every time you roll back. So let's trigger some rollbacks here. Ooh, I actually don't think we will trigger any rollbacks locally. I can create some artificial network delay here, and we'll see what happens. We'll see if this totally explodes or not. Let me get up my doc where I have these commands. I am typing things in a window you can't see. That is not very interesting. Here we go. Network, simulating latency. So let's add an artificial latency of 100 milliseconds. Operation not permitted. Sudo that. All right, so we now should have this 100 millisecond latency, which you can tell the round trip time has jumped up to 233 milliseconds here, and we are detecting that they are predicting 7 frames for us, and we are predicting 8 or 7 frames for them. And now if you should also be able to see some of the rubber banding. Ooh, did I break it? Oh no, I'm on the wrong keyboard. That's why it's doing weird things. Let's switch here. Okay, so you can see some of the rubber banding. Like, I don't know how well you can see it on stream because the stream is at 30 frames a second and the game is at 60, so maybe you don't. But I'm going in this circle, and you can sort of see the player like jerk over, and here it's showing we're rolling back 6 ticks, we're rolling back 5 ticks, rolling back 6 ticks. And it's basically, you know, it's predicting that I'm always pressing to the right. Oops. It's predicting that I'm always pressing to the right, and then suddenly I'm not, and it has to roll back 5 frames and update that. And you can see it the most when you're going in a circle, because not only am I not going right, I'm going in a completely different direction, and you get that rubber banding effect. That said, a round trip time of 232 milliseconds is pretty extreme. And this game is not terribly well suited to these kind of high latencies because you can move in any direction at any time. In Retro Tank Party, I think it will be better because you have to turn. And I think that that will make any correction be less obvious. Also, there's like other tricks we could do. Maybe we increase the input delay. I don't know. Lots of stuff to explore. I'm kind of thinking we'll try this in Retro Tank Party. If it turns out to be a disaster, we won't do it. But I'm really excited about this technique, and I'm really hoping that it'll work well. And I did a 4-player playtest on Wednesday, and it went way better than I thought it would. There was someone on stream last time, Thomas Schott, assuming he has the whatever. I always pronounce people's names as if they were Polish. His name might not be Polish. But so I'm sorry, Thomas, if you're watching and I'm butchering your name. But he was saying that this network synchronization technique does poorly with more than 2 players. And I had never really tried it. But we tried it. We tried it on Wednesday, and it seemed to work pretty okay. That said, we were not all in the same city, but we were all in the same region of the same country. So, you know, with higher latencies, things might be worse. Anyway, let's get down to some real things here. Let's dig into some code. So the way that this works is I have been working on putting all of the code for network sync rollback in this add-on with the idea that once I have this fully kind of thought through and fully debugged, I'm going to put it in the Godot asset library. So other folks who want to implement this in their Godot game will be able to. And of course, if you want to mess with it now, like all of this code is available on GitLab. I do almost all of my development in public. This is specifically in here. I'll put together like a full link to the branch and everything, so that if anyone wants to mess with this or see the code on a bigger screen rather than through stream. So here, I'll just paste this to you guys in case anyone is interested. Okay, so the main piece of this is this sync manager class, which is actually loaded as a singleton in Godot. So if we go to project settings, auto load, sync manager, so it's an object that is always accessible. And yeah, this is a bunch of stuff we were working on last time. It'd probably be difficult to talk through that. Let's talk through instead what it looks like when you're using the sync manager. So let's go look at our player scene here and the script associated with it. All right. So any node in a Godot scene that wants to participate in network synchronization with this sync manager adds itself to a group. Here we go, groups network underscore sync. And that is how the sync manager knows that it wants to deal with this node. And then you implement a bunch of methods on your node to interact with this system. So for example, we have underscore save state, which returns a dictionary. In this super simple game, the only state really is the position of your player. There's also the state of the animation, which if you remember from last week, if you were here last week, we were saving that in the state for the player as well. We're not doing that anymore. That's actually being saved in the state for the animation player. I will show that in a minute though. So it's taking whatever state it has, returning it as a dictionary, and then later if the sync manager decides we have to roll back, it grabs that same state, passes it here, and it just reconstitutes it. In this case, just setting position back. And then each node is responsible for gathering its own input. Last week, we weren't doing it like this, where the node was responsible. The sync manager was responsible, and we made like a subclass of the sync manager to gather the input. But this is better because the individual nodes know what input they want and what they're going to do with it. So any node that is depending on input will implement this get local input method, which returns a dictionary. Like I was saying last week, a dictionary is not the ideal data structure because we are passing this input over the network, and dictionary is serialized pretty big. But I did make one change to reduce the size of the serialization, and rather than using string keys, we are now using integer keys from this enum here. So even though it's still dictionary, and it's still kind of wasteful, we're at least not packing 10 bytes of string data in there. We're just putting an integer. So that's kind of my half measure. At some point, I will come up with some better data structure for this. But this is the simplest to use. So anyway, the player gathers all the input it needs. So it makes an input vector, which is just based on the player pressing up, down, left, right. This looks a little more complicated than it needs to be because it's setting it up so that it would work with an analog joystick. And it's dropping that in the input dictionary, and then it's checking, if the attack button was pressed, the space bar in this case, and then sets attack press to true. So only these two tiny bits of input. And then for not the local player, but for the other players, it also has this predict network input method where the sync manager passes it the input from the previous frame, and then it has to predict the input for the next frame, which, like we were saying, the simplest input prediction is just you're doing the same thing, duplicate it. Here we can be a little bit smarter though, because we want action just pressed, which we know will always be, if it was true this frame, will always be false the next frame, right? So we can make an assumption in our network, in our input prediction, that this is just always, we're going to predict the attack to be false. And you also notice too that we're erasing it rather than setting it to false. And that's again kind of an optimization for the fact that we're passing this dictionary over the network. We're depending a lot on default values. So an empty dictionary will be the input that we pass back when no input is being made at all, so that we can make that message be as small as possible. And then we are doing all of our work in this network process function. Let me take a sip of tea. And this is supposed to be kind of like a replacement for the _physics_process method in Godot, where you would normally do things with your input. And it still is happening during the physics tick, which is important because in Godot you can't mess with physics objects or the physics engine unless you're inside of the physics tick. But it is not exactly the same as the physics tick because sometimes it won't happen. If we've decided that we are going to skip a frame because another peer is falling behind, then maybe a physics tick will go by, but a network process won't happen because we're skipping it. Or when we're doing a rollback and a roll forward, it might be one physics tick and network process gets called 3 times. If we're doing a 3-frame rollback, then 3 times this will happen within a single tick, which is why we need a different method. So anyway, it's past the delta, which is basically whatever the real world time our ticks are supposed to be. I don't know if this is something I should be doing. I'm kind of a mixed I have mixed feelings about it, but whatever, it's fine for now at least. So we know that we're running at 60 frames a second, so this will always be, 1/60th of a second here. It's being passed to the input that we are using for this particular frame, which could be real local input, or it could be predicted input. The sync manager knows what it's giving to us, but it's always giving us something. And then we are taking that and acting on it. So in the case of this super simple game, the player is taking the input vector and moving the player. We're checking if attack is being pressed, and then we are attacking unless we are already attacking, which we find out by checking the animation player. If the animation is playing, then we're attacking. So if it's not playing, then we start it attacking. Whew. Hopefully all that made sense, but this is basically how, in your game, using my asset, you would do what you need to do to make the rollback network synchronization happen. And we're going to be doing all of these kind of things, implementing all of these kind of methods in Retro Tank Party in a moment to try and bring this over to that game. So I said I was going to talk about Animation Player. In this add-on, this asset, I've also have a couple of other helper classes, this network animation player and network timer. And you can attach those scripts to, you could attach like network animation player to an animation player, which is what I've done here because I was kind of converting this. But you can also go just add a node, and it's adding it as a custom type. So this script added to an animation player does all of the things to make this animation player work with this rollback synchronization method. It adds the animation player to the network sync group. It changes some of its properties to work here. I mean, normally animation player, when it calls a method, would actually call the method during the next physics tick, which we don't want to happen. We change it to be immediate. Normally an animation player would advance itself as real world time goes by. We don't want that to happen. We mark it as manual. And in fact, what we do on the network process is we check if the animation player is playing, and then we advance it whatever the real world time should be for that frame, even if that time isn't going by because we're rolling back or rolling forward or whatever. And then of course saving and loading state. It's saving are we playing, what the animation is, what the current position is. When it loads state, it brings us back to that right spot. So theoretically, you could still use animation players the way you are used to in Godot, attach the script, and have them work with rollback. It might not be 100% perfect. I don't have enough experience with it to say exactly how imperfect it is. But because the animation player works in seconds, everything is defined in seconds, these floating point values of seconds, they might not, the math with those seconds might not work exactly the same on every machine. Floating point math on a Windows AMD 64 might work different than on Linux on a 32-bit x86 or whatever, and certainly different than it would work in HTML5 or on a ARM architecture on a Mac, right? So depending on how imperfect there probably is some solution. One of the ideas that I got from an article, which might be enough, is just to reduce precision. So I don't know exactly what this delta float is. Is it 0.166666667, or is it 0.1666666666667? Right? Maybe we just pick a value that is imprecise enough, like just maybe 1 point or just 0.1667, right? Real short with not very much precision, and maybe that will be close enough on all of the platforms, and then be fine. Or in the worst case scenario, maybe dealing with seconds at all is a disaster, and we have to stop using the normal animation player and make like our network tween or something and animate things that way. I don't know, but this is what we have for now. I also made this network timer, which is meant to be an analog to the normal Godot timer, but this time working on ticks. Let me find where I have one. Okay, so this restart timer. This timer is used by the game once a match is won to decide when to start the next match. So once it registers a win, it starts the timer going. When the timer goes off, then the next round begins. We can't do that in seconds because that won't be perfectly synchronized over the network. We instead do it in ticks. So this has a lot of the same variables as a normal timer would. Auto start one shot, but instead of wait time, we've wait ticks. And then this new timeout with incomplete input method, which I'm not sure entirely how to deal with that in the future. As we get more experience, yeah, another thing we need to just kind of experiment with. But what this is, this timeout with incomplete input, is that the timer will count a certain number of frames and then emit its signal. It's a timeout signal, just like the normal timer. But maybe we want it to not emit that signal unless we have already gotten input from everyone, right? Because we know we're always going to roll back and rerun a thing eventually once we get the real input, right? And so maybe we just like don't time out if we don't have all the input. And maybe that's a bad idea. Maybe it's not. Maybe it's a really good idea and it should always act that way. But for now, I have it as an option and I'm using it here. So we register the win, but we don't know if we really won until we get all of the input. Like what if once we get the other player's input, we roll back and realize, oh no, the other player actually attacked slightly before the player we thought won, and then they kill them. And then really the win should go to a different player. So maybe we shouldn't be deciding who wins or who loses until we have all the input in, and that can be done with this timer, right? So it's a pretty simple script. You know, we're just on the network process, you know, counting down ticks. If it's one shot, we stop it. If it's not one shot, we start it up again, blah, blah, blah. But here we have this thing where we say, sync manager is current player input complete. And that basically says the frame that we're currently simulating, do we have all the input? Yes or no? So that is another tool in our tool belt. Let's see how useful it is. Is there anything else I want to tell you guys about this before digging in? Yeah, I already mentioned that I added an input delay from the last stream. We also switched in the previous stream, we were sending messages with reliable RPCs. We switched to sending them through unreliable, which should be faster. And we're verifying, we're using a different technique to make sure that no information is lost. Basically, we keep sending the old information until we're sure that they have gotten it. So we don't need the added low-level reliable stuff. Yeah, I think I've covered everything. All right, let's do this. Let's do this. Do I have RetroTank Party open? I do. So, to get started here, we are going to copy that add-on from our demo project into RetroTank Party. Let me just make sure that I made a branch. Ooh, and I'll make the text here a little bigger, because I know that's tiny text. That's nice and big. Let me know if you guys still can't see that. And we're on a new rollback branch. That's good. Let us recursively copy from this Godot Nakama add-on network sync rollback. We're going to copy it into our add-ons folder. Boom. All right, so we have the files there now. We have to do a couple of things. The plugin, we have to go here and enable it. What? I wonder what the error is. That's interesting. Wasn't getting an error in the other thing. Let me go open up that file, see what's going on. Plugin GD. Could not fully. Oh. Okay. Huh. Cyclic reference. Oh, you know what? I bet it can't open it because it's making a reference to the sync manager. Let's check that out. So it's having trouble loading network timer. Totally, it's making reference to sync manager. Wow, okay, so I'll have to change this before I put it on the actual Godot asset library so it's easier to enable. But what I think we have to do is we have to go add the sync manager singleton first and then enable the plugin. So we'll go add the sync manager, and we'll also add this other script here, the sync debugger. That's what is printing out all of the stuff to the logs and what is adding the overlay that we get when we press F1. So it's optional. You don't need to include it, but if you include it, you get that extra debug functionality. So then maybe in the production version, you could like remove it or something. Although I'm definitely keeping it in so that when people have problems, I can be like, send me your logs. And then I can take a look and see what's going on there. All right, so we've added that. And this error should go away once we trigger something to happen. Maybe I have to like add a line or add a character or something. There we go. Okay. So now that error went away, and let's again try to enable the plugin. Seriously? All right. When in doubt, close the Godot editor and open it again. As all things in technology. Turn it off and turn it on again. All right. Now let's try enabling that. Woo! Worked this time. All right. So we have it enabled. We do need to do a little bit of boilerplate to tell it what the peers that are connected are, and we need to start it before it'll actually do anything. So let's do that right away. And I think we want to do that in game. Let's see. We'll find the right place for this. So I think game, we want game to start the sync manager. That is for sure. But I don't think we want game to add the peers. I guess we could have game add the peers. It feels wrong though. Like something higher up than game should add the peers. Okay, let's see. We know we want to start. So game setup. That's when everyone's getting going. Then we mark this operation done. What is the RPC that kicks things off? Game start. Actually start the game on this client. This sounds like the place. This sounds like the place. So as soon as we unpause, we'll do sync manager start. All right. And where should we add the peers? Let's go to, or actually, okay. I think this is the right place, but maybe it's not. Let's go look at the high level, the top level scene that opens this, which is match. Okay, so I'm kind of two minds that maybe match is the one that should be adding or starting the sync manager, but it's definitely the place that should be adding the peers. So when this scene starts in our scene setup, what do we get? Do we get a list of the peers, or do we just need to grab them from Godot here? Scene setup, match manager, blah, blah, blah. Operation mark done. What info are we getting? What is the match manager getting? Let me just go look at one of the match managers. This game has acquired a lot of indirection. The different game modes are actually done by these match manager scenes so that it's easy to add new game modes. We'll go look at, let's say, the Battle Royale match manager. And what sort of info does it get? It gets a list of players. Where does it get the list of players from, though? Match setup. Let me just search here. Setup players. Oh, it's just grabbing it from the online match. It's not being passed anywhere. So I guess that's what we should do in match here. When the match top level scene starts, during scene setup, before we mark things as done, we're going to grab the list of players. And it is players by peer ID, which means we can go for peer ID in, and we could say sync manager add peer and peer ID. Okay, so that will get the peer IDs added, and then this player left. Come on, just jump to that for me. On player left, we'll need to remove the peer from the sync manager. Otherwise, the sync manager will just perpetually be waiting for their input, and it could actually cause synchronization to be lost. There's a bunch of fallbacks in sync manager, like if it starts retiring input frames that are missing player input, it will error out and say synchronization lost, because if it gets that input someday, like if it comes in later, there's no way we can roll back anymore because we've already discarded that frame since we're only keeping 20, a maximum of 20 frames. So sync manager, remove peer, player peer ID, bam. All right, so we are adding all of the peers. We're starting it. We need to stop it somewhere. Where do we stop it? We need a place that will stop it no matter why we are stopping it, whether we're stopping it because we won or we stop it because there was an error or whatever. So it looks like match error will always be called in the case of an error. Do sync manager stop. And oh, interesting. I wonder if these quit match and finish match will always be called. Let's take a look at those. Finish match. Stop, blah, blah, blah. Quit match, leave. So wait, down here we call quit match. Okay, okay. Quit match. We can move that over to quit match. And we'll do it first thing. Sync manager, stop, and finish match. We'll do it here too. I have a feeling these are the two exit points. But I'm not 100% sure. Let's just look around a little bit more. When we press the back button, we show the menu screen exit pressed. This will always lead to either finish match or quit match. Okay. We will get some very loud errors if we got that wrong. Oh, actually we won't. We won't get the errors unless we connect to the signal to get the errors. Okay, so we got to connect to sync manager. And what is it? It is sync error. And we'll do on sync manager, sync error. And then we can be very loud. This is where we're going to be very loud when there's a sync error. Where's the right place to put this? Online callbacks. Maybe at the end of all these online callbacks. Sync manager, sync error. And I forget the arguments to sync error. Let's go take a look. That would be in sync manager. Why don't I see you? Okay, maybe we haven't opened it in this project yet. Sync manager. Okay. And its signal for sync error, it just is passed a message string. So let's go back to, that was in match. Passed a message. And I don't think we actually want to use that message because that message is a technical message with the idea that maybe it would log it. And that's what the sync debugger is doing. It's logging it. But we need the right number of arguments. Otherwise, there will be a problem. And here we'll put an underscore in front of it because Godot will give a warning if we don't use an argument. Okay, and then what we want to do is call the normal error handler. I guess this one. And we're going to say synchronization lost. All right. Let's go make sure that does what we want. It shows the message, it hides the UI layer, it waits 2 seconds, then it quits the match. That seems fine. We don't have to worry about it being a 2-second timer, not a frame-based timer, because we've already lost synchronization. So next up, I think we get down to the interesting stuff, where we're actually going to be modifying the player script to use all of the new methods we need it to use. And we're also going to have to tear out a bunch of stuff that it's already doing so it doesn't get in the way. How are we doing on time? I guess, okay, we have an hour left. Wow. I spent a lot of time in the intro stuff, guys. But we'll try and make some headway here. I hope this is still interesting for you guys. Definitely, if you have any questions or comments or ideas about what I should do, let me know. Otherwise, I'm just going to keep plowing right ahead here. I always feel better when people are saying things, you know? Like, otherwise I just worried I'm talking to myself in a room. Even if people are saying, like, mean things, I feel more like I'm in a conversation than just talking to myself. All right, let's see. We need to find the scene that controls the player, which I believe is under Objects, Tank. Yes. So this is our lovely tank. We have a bunch of things I see right away that we're gonna have to change, where the weapon firing is done with a timer, you know, 0.25 seconds. We'll have to translate that to ticks and make it be a network timer. There is an animation player. We'll have to add the script to deal with the animation player. Sound. I haven't even had a chance to think about sound in the context of Godot yet. There's this really great article that I saw in Gama Sutra. I actually had it open earlier because I wanted to see if I could use one of their diagrams instead of my terrible diagram here. Inversus? Yeah, this one. This has been, for me, the most accessible article about rollback networking from this guy who implemented it in this game Inversus, and I'd ended up not really liking his diagrams for my own personal use. But he does talk about how he handled sound in rollback, and that's going to be interesting. Hey, Sebas. Oh, some other people here. What is that? Want to be famous? I don't want to be famous. And cold cardio? Oh, some more people new to Godot and to gaming stuff. Cool. Thanks, Sebas and Cold, for coming by and hanging out. I hope this isn't too advanced stuff, but you know, you're just getting into Godot. This is some cool stuff that maybe you'll be able to use later when you're digging into some online multiplayer games, which I hope you will. Certainly drop me a line, let me know if you do. And yeah, like, guys, tell me what you're working on, like what game you're making, because it'd be super cool just to know what kind of projects you have going, especially if they're online multiplayer, because I love geeking out with people about stuff that's the same stuff that I'm working on. Obviously, I think everyone likes to do that. But yeah, let me know what you're making. All right, so let's do some real work here. We'll get to the tank script, and let's go look at the current sync code. Just want to get this part to go away. All right, so the current sync code, like I said, is super naive. Let me find it. So here's our physics process where we're processing all the things, and then we are calling an RPC, receive remote update, and then that goes to receive remote update, which there's a lot of indirection in this game, like I mentioned before. It goes into this hook system. This is for modding and for not modding, for like just interesting things in the game, to be able to intercept different things that the tank is doing and make changes. So for example, when you use the boost power-up in the game, it makes you go real fast in one direction for a second. That's done with a hook. It like takes over your ability to send input and changes it while you're using that ability. Anyway, so this is calling this receive remote input, which goes into this hook. You can ignore the hook part of it. The default implementation of the hook, oh no, here's the default implementation of the receive hook. It just takes that data that we are sending it, which is state data. This isn't input data. This is saying, here's my position, here's my rotation, here's my current rotation, here's what weapon I have, here's if I'm shooting or not, and updates it. So all of this stuff we need to not happen. So for now, we are going to just get rid of this, which is going to break like a bunch of weapons and power-ups and stuff too until we fully make this conversion. We also need to switch from physics process to our new network process. We're going to take an input dictionary and a sync manager, which now that I'm thinking about it, we don't need to take because sync manager is now a singleton. It's a thing that's has one instance that's available everywhere, whereas earlier on, when I was implementing this, it wasn't a singleton. So anyway, we probably don't need that, but it's one of the arguments right now. And we're going to need to separate everything that does inputs, including this, into a get local input method. But before I do that, I want to just quickly add this node to the network sync group before I forget to do that. because otherwise we'll be wondering why nothing is doing anything. And yeah, so network process first. We'll deal with state last. We'll deal with input network process first, because I think we can test that by going into practice mode. Whereas we'll need the state stuff for when we're testing it in real network mode. And there's a lot of input stuff. Okay, so we'll want to still use the same hook scheme. But I think... Wow, a project that gets this tangly gets a little bit difficult to convert here. So we need to move this input stuff out of here to somewhere else. And I'm not entirely sure where that should be. Let's just start writing it and see where we get. Get local input. I don't remember if that takes any arguments. Oh, but it definitely doesn't return void. It returns a dictionary. Checking the comments real quick. Cool, so Cole's just getting into Godot to build a game similar to Browser Quest. Yeah, so how to start learning Godot. There are some really great tutorials. All the stuff by GDQuest is really great. I haven't done their like, you're just starting Godot tutorial, but they do have one. I mostly look at their like specific ones because they have like individual tutorials about everything. It's really great. But there is one like sort of intro to Godot tutorial that I can really recommend because I have gone through it. It is Heartbeast's action RPG tutorial. Yeah, make an action RPG in Godot 3.2. I think this is the one. Should be a whole playlist though. Give me the playlist. Maybe we'll go to Heartbeast channel. I'll find the playlist and I'll post it in the chat for you guys. Godot action RPG series. Here we go. This is really good. I don't know if you want to make something action RPG-ish or if you even like action RPGs, but this is a great tutorial. Oh, and it looks like Semos is in the same kind of situation. Oh, and he's watching some of my GitLab videos. Awesome. I have a new one coming out on Monday, assuming I get it finished. It's not finished yet. All right. That's awesome though, guys. I'm glad you're getting into Godot. Okay, this is the wrong project. Where's the right project? Okay, where did we leave off? On gathering input. So we need to make an input dictionary, which we are going to return. And we need to fill this up with some stuff. We are definitely going to fill it up with the input vector, although, do we want just the vector? I have a feeling we don't just want the vector. Yeah, I spent a bunch of time thinking about this like weeks ago. I think we don't necessarily want the vector. We want the actual inputs because we have these two control schemes. And they work very, very differently, such that I don't think we can predict the next input vector, like for the input prediction part of this, without knowing the control scheme. And the prediction is going to be way easier if we're predicting the button presses and not like what the resulting calculated vector should be. So that that makes things more complicated. How about this? We'll ignore that for now. We'll ignore that for now just to try and get something working. And then later we'll come back and try and fix it. And we're just going to assume that we're only using the retro control scheme. So let's do input vector equals get input vector. So this means the least amount of changes, or actually here, we also don't want to pass a 0 vector to cut down on how much we're passing over the network. So let's do input vector equals this, and we'll say if input vector does not equal the 0 vector, then we will assign it. Boom. All right. And we also need to get this other aiming input. You know, how are we going to predict the aiming? That's going to be interesting for prediction. How are we storing we're storing it as a rotation? Okay, so that's nice. The turret rotation is the input. And I guess we're doing these to deal with the difference between aiming with the analog stick and aiming with the mouse. So let's just start by copying and pasting all this up here. And we will modify it. So we don't want to just straight up look at it. What we want to get out of this is a rotation value, because that is easier to predict. And the only thing we can predict when they're using the gamepad is a rotation. Or no, I guess we could predict a vector, but do we want to predict a vector or do we want to predict a rotation? Rotation is a single float. It's ultimately what we're setting. So I think we want to predict a rotation. Let's predict a rotation. And it's going to be hard to not send the rotation every single frame, because there isn't really like a null value for rotation as there is for like movement. There's no movement, but you're always rotated to something. That kind of sucks, but it's going to be a single float, so hopefully that won't be too bad. Single float is just, well, I guess 8 bytes, and then the bytes to tell us it's a float and blah, blah, blah. But we'll try it. We'll try it. We'll see how it goes. So, how do we calculate just a rotation from here? We are going to need to do what? So we need to think about our current position, where the turret pivot is, the location of the mouse position. We have this very convenient look at method. So the turret pivot currently has a rotation. You want to rotate to look at this. It's much easier for the for the gamepad, I think. All right, so we're going to start with the position. So we'll say turret position equals turret pivot global position. And its rotation also matters. Oh man. Well, no, its rotation doesn't matter, because we don't care what its current rotation is. We're just snapping to whatever it is. It's not a relative rotation, it's an absolute rotation. And we're getting a vector that points from this position to that position. So actually, hang on. So turret vector, and we want the destination, global mouse position, minus the turret position. That's a little bit of trigonometry for you, if that is trigonometry. Is it trigonometry or vector is trigonometry? I don't know. So that should give us the vector pointing from turret position to the global mouse position. And then we need to know what that rotation is, so we'll say turret rotation would be the turret vector angle, right? Right? Someone check my math. I think we could definitely write this with less code. And we probably should. I just needed to make all those in-between variables to think through this in my mind. We could actually just simplify this to global mouse position minus turret pivot global position. There we go. All right, I didn't even have to take out a piece of paper, assuming that's right. Please let me know if it's wrong. All right, so that is mouse control. which is the first thing we're going to be testing. In fact, let's just pretend that we don't have gamepad control. Because it's only one thing we have to do. Once we get this working, we can come back and do gamepad control. So I guess, yeah, we won't even check. We won't even check if it's mouse control. We'll just say, bam. We're always going to be sending the turret rotation and an input vector if we are moving. So now let's predict some input. So that's predict remote input, I think. Just double check that that's the right name of the method. And the player. Predict network input. Okay. Predict network input. It probably should be remote because like local, the opposite of local is remote. Let me make a note about that. I might rename that. Rename get network input to remote. Oh, and there's also was the note about in network process, we want to get rid of the sync manager argument. Network process. I do too much on paper. I'm sorry. Makes me slow. But I like paper because I can always find it. When I type things on the screen, especially I'm doing a stream, I'm like, where's my window? Where's my window? All right, so remove sync manager. All right. Andy K is asking, is it possible to sync mouse position and all clients' turrets just look at this position? Just an idea. Yeah, we could do that. The input could be the mouse position. That makes things a little bit trickier with having the two control schemes, though, with the mouse control and the gamepad control. Because then we would have to say, okay, if you're using the mouse, we'll send the mouse position. And if you're using the gamepad, we'll send, I guess that would be a vector, is kind of like the native thing that you would get from taking those two input strengths. But this way, we can boil both down to a rotation. So if it's mouse control, we can send a rotation, and if it's a gamepad, we can send rotation. But we totally could. We totally could sync mouse position. That is a possible way to do it here. So predict network input, and we're getting previous input dictionary, and we haven't dealt anything with shooting yet. Let's just ignore shooting. We'll start by only synchronizing the movement. We'll get to shooting next. So I think we can just duplicate this. Let's just say our previous input is the same. Our next input, our predicted input, is the same as our previous input. Bam. Predicted. And what is next? We have the network process. It's passing in this information. Oh, we need to have it start using the data that we're passing in. So this needs to be input vector. Down here, we need to, let's just comment this all out and replace it because we're not doing both control schemes. Or actually, yeah, no, we wouldn't ever need it. So okay. Here's what we'll do. Since we're always going to pass it, because you could always switch between gamepad and mouse, we're just going to like always set this. So turret pivot, global rotation equals input turret rotation. You also notice that I've gone back to using strings as the identifiers in the dictionary, which we should not do. We should switch those to integers and nums. But for now, for just like getting this thing working at all, we're going to do this. If shooting, where do we decide if we're shooting or not? Oh, in here. Okay. That's interesting. I must have done that to try and prevent shooting from happening when you're clicking buttons. Putting it in unhandled input, because things will only go to unhandled input if some other node didn't claim them, like a button would say, I took your click, it's mine. Same with abilities, although I don't think we have any UI that deals with right clicks. Anyway, let's just comment this all out for now. We're going to pretend shooting doesn't exist. So we're going to just get rid of this stuff. Yeah, this is fine. I can leave that there for now. So we get the input. We predict the input. We process the input. Oh, and it's doing like... Yeah, this is going to need to change. This is going to need to go into the get local input as well. Or does it? Hang on, hang on. Rotation is really close. We just snap. Do we know if our rotation is really close when we're getting input? We do. We do. This can go and get local input. Yeah, it can, and it should. We're going to comment it out now, though, because it deals with that other control scheme that we're pretending doesn't exist. The engine sounds depending on the input vector. And actually, the way that the engine sounds work, I think this should be fine for switching to the new networking synchronization model, because it's setting a variable that is then looked at later. And we are doing the move and slide and everything here. We're updating the pivot here. This might be good. This might be good. Let's see how it explodes when we try to run it. All right, let's see what happens. We're going to run it in practice mode, which should still use the sync manager, because the practice mode... Oop. What did we get? Could not get... Oh, okay, right, because we have to always assume that there could be default values, because when we're predicting input, we might just plain not know. So get input vector, vector to 0. So if there is no input vector, then it is 0. And same here. If... Do we really want to... Okay, here, a different strategy here. We're going to say if not input has turret rotation, then... Or no, only if it does have. If it does have turret rotation, then we set it. I want to do that one differently, because if we default to turret rotation being 0, since we're setting global rotation, that means when there's no turret information available, all the turrets are going to point straight to the right, which we don't want. We want them to stay where they are until we have a turret rotation, because like the initial position of the tanks will have the turrets pointed in a logical direction. Okay. As to rotation, do that. That should be good. Let's start this over. Practice. Ooh, I'm driving. Haha. I can't shoot, but I'm driving. All right. Cool. I was expecting this to explode way more than that. Wow. Okay, cool. So we have the input and network process working. The next thing we need is the state stuff. That will allow us to actually try this in a network game and see what happens. Yeah, let me just put this below all of this stuff. Say func. No, we'll start with save state. Up. And we're going to return... The only state we care about right now, because we're not syncing everything yet, is the position, the rotation of the whole tank, and the rotation of the turret. Yes. The rotation of the turret is important because if we get input later that says we are shooting, then we'll need to have the right rotation. But maybe it doesn't matter, because we're also, every single time we're getting input, getting the turret rotation. So maybe we don't need to save the turret rotation because it's always input. Let's try not saving it and see what happens. So position, we can just do normal position. We don't need to mess around with global position because we're always putting the state back into the exact same node. And same with rotation. We can just take rotation. Is it really that simple? I guess we'll find out. Man, I don't usually type this bad. I type way worse on stream. Or I guess you'll have to take my word for that, but it's the truth. I get nervous. Okay, so we are now saving and loading state. Let's just run it again in practice mode to make sure that it doesn't crash. All right, not crashing. Good. And we'll set up 2 clients. I guess I could have left that one running. Do battle. Bulk match. There we go, it's looking. We are almost connected. That was oddly slow for a local game. I'll do Battle Royale, all default settings because it's old school. Ooh, crash right away. All right, what do we got? Cannot add ourselves as peer in Sync Manager. Thank you. So what I think was going wrong at the end of the last stream, because it kind of worked, like we moved a little bit, but like sometimes it wouldn't move us, is that we accidentally were adding ourselves as a peer. So it was trying to like predict and correct our own input, which is of course terrible. So I added this assertion because like while I was working on it last week, I kept accidentally adding myself as a peer. So where is the code where we are adding the peers? I think we put that in match. Match, match, match. Here we go. And that was way up at the top, if I remember right. Yeah. So now we gotta say if peer ID is not equal get tree, get unique. Oh, network unique ID. I love that autocomplete. Okay, that should work. Let's start over. And what? And we'll have to start this one over too. Yep, good. Start. It's locked up. Something's not working. Something's not working. All right, what are you saying over here? Ooh, we got a whole bunch of errors in the debugger. Let's go take a look at those. They might ooh, okay. Input map. Oh, okay, so I need to add a input map thing for our debugger. Network sync lost. Why didn't that put up a big error message for us? It should have. Ooh, error calling method sync error. Method not found. Oh, typo there. Okay, bunch of little typos and little things we got to do. So let's go down the list. This one that's spamming us. Let's do that first. We have to add a sync debug action that our sync debugger is looking for. We're going to bind it to the same key to F11 because I like that key. And the next thing we need to do is this signal here. We did that in match, I think, again. Match was where we were checking if there was a sync error. Okay, match. Sync error on sync manager? Sync manager. Let's make sure I type this right. I'll just search for it. Yep, okay. Take 3. If we get this working in less than 5 tries, that will be amazing. Synchronization lost. All right, it failed the way it should have, so that's definitely a step in the right direction. So what do we got in our logging? Correcting prediction on tick 1, rollback of 12 ticks. That is a huge rollback, 12 ticks. Received that input, we predicted nothing. So that seems fine. Rollback of 12 ticks though. Wow. Oh, you know what it is? I never disabled the thing that was adding the artificial network delay. All right, let me go copy and paste the thing that will get rid of that. Let's run this command. Oop. No more network delay or artificial, network delay. And let's try this again. That might just fix it because like that's a lot of delay. And we might just not have enough, a big enough buffer to deal with that much delay in this game. Of course, there could be other problems, but here we are. Take 4. Is it working? Is it working? No, it's not working. So, like, where do you see the other dude? Do you see him anywhere? Okay, so you see him up there. And I see you down here. But, we are not synchronizing. What's going on? Let me, Okay, yeah. Wow, it's finding a ton of state mismatches, as it should. Our state is totally wrong. Let's stop this. See what we got here. Narrowing conversion. Float is converted to int and loses precision. Oh, okay. This is just a warning I'd never seen before, but caught my eye because we're dealing with like floating point issues potentially. Okay, so something's going wrong. We appear to be getting state correct because if we look at the output here, on the state validation that's coming back, it's saying on this tick, remote state from 2 doesn't match local state. The remote data, yeah, just has the positions way off because they are way off. So why is the input not applying here? Am I even looking in the right script? I want to be looking in the script. Okay. It's working locally, so that's a good sign because we are using the sync manager to do all of the local stuff too. It's always coming through network process. It's always getting input from here. I just don't know why the input would be like not making it, you know? Let's go see if there's some messages early on. Okay, a rollback of only 4 ticks. That's much nicer. Received input. So receiving input from peer 2, root match game players 2 with a turret position. It is never returning, or at least it's giving a turret position, but not an input vector. So let's go see what might be wrong there. Oh, here it is. This is totally it. So the old code had this if player controlled. We would only be doing things with the input if this particular tank was player controlled. We need to get rid of that. Get rid of that, and then we'll unindent everything in here. Because we now want to always be doing stuff, whether it's player controlled or not. This screwed up my commenting out of lines. Just no, the other way. Thank you. I like to thank my computer. I feel like if I'm polite to it, once the AI apocalypse comes, then maybe it'll be nice to me, take mercy on me. All right, okay. So that should totally fix it. Is this try 5? Is anyone counting still? This might be try 5, it might be try 6. I'm not sure. Let's quit this one out. Oh, now this one's the host. That's less optimal, because then I won't see the error messages in the Godot editor, but whatever. Ah, we got an error right away! Start should only be called on the host. Really? Oh, okay, I guess. So then the place I put start is wrong. Okay, so here's what this code is doing. You call start from the host, and then it coordinates starting all of the other peers at the same time. And the reason that it's doing that is for a feature that I haven't implemented yet, and maybe never will implement. We'll see. The idea, and I got this from this Inverses article over here, is that you know that the other peers are going to actually start their games at a later point than you, so you can delay your start by some amount of time taking into account the other peers' latency. And the problem that this is working around is that at the beginning of a match, if you don't do this, if you don't delay your own start, the host will always have to roll back a whole bunch of frames. because the host will start immediately, and the other peers won't start until whatever the latency time has gone by, which means they'll send their input late, which means the host has to roll back and probably even skip frames. It probably has to both roll back and skip frames. So the host will always get this like sort of jitter at the beginning of the match. And the way to work around that is to look at the latency information with all of the peers, say, okay, I'm going to start all those peers, but then I'm going to wait a little bit before I start myself. And that's why we have this start method that's called only on the host that then does a coordinated start itself, as opposed to us just starting, on the host all the time. So that means the place that we put this start call is wrong. Let me get back to game. I think we put it in the game script. Yes, we did. And we put it on the coordinated start over here. So instead of putting it here, I think we still need to do it here, actually. We still need to do it here, but we need to only do it for the host. That's kind of funky. So game is doing its own coordinated start. It's doing game setup to basically prepare the whole game, like loading the map, instancing all the tanks, and then saying like, okay, everyone report back that you're ready. And then once everyone says they're ready, then it says, okay, time to start. But we can't start the sync manager until the game has unpaused, I don't think, because things will get weird. Or maybe they won't get weird. Maybe they'll be perfectly fine, because if the game is paused, the sync manager won't run either. Maybe they'll be fine. Let's try it. Or no. I'm debating in my mind whether we should try the risky thing that might just work, or the safe thing that will be inefficient but will totally work, because my gut inclination is always to try the risky thing first, and if it works, hey, maybe we're cool. But we won't actually know if that's true because we're only testing on my local computer, right? So we might try a risky thing that works on my local computer, but then once I try it with like a real game with people over the network, then it'll fail, and I don't want to totally confuse myself later. So let's do the safe thing. We'll say if get tree, not get transform, if get tree is network server, then we will start. So the host will unpause itself, then it will start the sync manager, which will do that second coordinated start. So we're doing like a coordinated start after another coordinated start. All right, let's try this. This is definitely at least try number 6. We didn't make it in 5 tries. We weren't that lucky today. All right, driving over there. Ha! It's working! Woo! Both ways even? Okay, we have got some rollback synchronization. Through my headphones, I'm hearing a lot of noise. I don't know if I turned off the audio. No, so you guys must be hearing it too. There's yeah, it's like I can hear it like phasing together, the different engine noise. And I don't know if that would have happened in the old version of the game running 2 clients at the same time, or if that's an artifact of us doing something dumb with sound in this version of the game. But yeah, cool. So that's a start. That's a start. I will commit that. Ooh, will it exit normally? And it exited normally too. Let's look at some of this information here. Wow, it didn't even output that much stuff. So RTT is fine. I don't see it. Oh, it skipped 1 local frame to resync the ticks. Let's go look at the host is this one. That should give us some more information because it has that like state check. Ah, sweet. So it skipped 1 frame to adjust for peer advantage. Cool. Oh, I can actually see it right here. Peer advantage got up to 2. So it needed to skip a frame to get them more in line. Yeah, you can actually see it here totally. Remote lag 0, 0, 0. That means they are predicting 0 frames for us, but we are predicting 2 and 3 frames for them, which it gives them a big advantage and means that we have lots of rubber banding. And so then it adjusts, and then we go back to a lag of 1, 2, 1, 1. See, we're back synced here with advantage of 0. So that worked perfectly. and it is giving us no messages related to the state being out of sync, which is fabulous. I didn't push it in any kind of way. Actually, let's try to push it. Let's just push it a little bit. And by push it, I mean do things that I think will cause the physics engine to get out of sync, which are things like running into the other tank, running into obstacles, because then we might get some of the imprecision. All right, hit this tree a little bit, drive around like an idiot for a little bit. Go crash into the other tank a little bit. This would be better if I had another player to like move around the other tank so we could crash into each other while moving, because that, you know, just screams of physics engine issues. We could even test this with folks on the stream actually and see how it works, and the overlay should work. Yep, there's the overlay. So we can see how well this works. All right, so I did some things that I thought would maybe get our state out of whack, and our state is not out of whack. It's perfectly fine. Holy cow. Let's go see any alarming messages here. Oh. Guys, we should test this for real. Is anyone still watching? Oh, I still got 7 little eyeballs. 7 little eyeballs on there. Let me commit this, and I'll tell you guys where you can get the build from. And we can try and see if anyone's interested, if anyone can, if you guys have the time. So I know some people watch streams like, you know, while they're working in another window or something. So maybe you don't have the time, but I would love to see how this works in practice. First pass at converting to rollback. All right, let's push this up. And because I'm doing all of the builds with GitLab CI, and everything is public, you guys can come into the pipelines page for, oh, this is the wrong project though. This is that demo project. Let me get this to Retro Tank Party. Go over to the pipelines page, and ooh, we got some old builds running. Oh, haha, I did some Steam builds last night, and I forgot to start my Mac and Cloud, and they're just sitting here paused. Okay, well, after the stream, I'm going to start my Mac and Cloud. I would start it right now, but I just don't want to do anything that could maybe like screw up the stream. Anyway, so here is the build happening for all of these different platforms, and when it's done, you guys will be able to come over here and click this little dots and download the build. And I'll download it from here too, actually, because I have to be using the exact same version built from the exact same Git commit in order for us to connect, because there's kind of like a safety thing built in there for that. So, Andy K says he's in. Gbon Art, I don't know how you want to pronounce your Gbon, is working. I don't know if that means you can play or not. Damon still watching but can't participate in the test. Well, you know, if we can get you know, at least one other person over the internet, that's something. It would be so cool to get you know, a couple more people in there. All right, so I'll put this link in the chat. I'll say pipelines page to download the build. And if you guys go to this page and click on these little dots, oops, I have to reload the page for the dots to contain anything. Hang on. Click on these dots. It will have download Linux, web, macOS, Windows archive. Download the right one for your platform. I will download the Linux version here. And load it up. Give me a second to do that. What do I have in here? I have another build I was doing. Let's do zip, Retro Tank Party, Linux. All right, and let me start this up. On, because I'm using a real build, I'll get the little intro screen here. I'll get you guys a match ID. Oh, cool. That's fine. Gbon, you're doing your own hacking while you're listening to This stuff, okay, I don't know why I have to enter this, it should have saved it. I'll probably mess up typing my password. Yep, because I'm on stream, I type terribly. All right, let's make a match. We'll see if it's just you and me, Andy K. That's fine too. I'm super curious to see what happens. Oh, and Ross is getting in. Awesome. We'll get Ross. We'll get Andy K. I am super curious to see what this does. There's, of course, even if this works, there's still like a monumental amount of work necessary to complete the conversion. Ooh, Ricardo's in here too. Sir Tanks a lot. I like calling you Sir Tanks a lot. We're even gonna get a four-player match. We can't hurt each other, but cool. Ah! It lasted 4 seconds. Not even 4 seconds. 2 seconds? 1 second? Oh my god. Let's try that again. Let's see if it's so short. If that fails again super fast, what I'll do is I'll make a new build and I'll increase the buffer size. We'll like double the buffer size. We'll go from 20 frames to 40 frames and see if that keeps synchronization. Because I like really don't know what the right number of frames is, honestly, to save, like how that works with latency and packet loss and all those different things. So maybe it needs to be higher. Maybe I'll just set it to like an extreme high value. Oh hey, yeah, Ross, if your firewall blocked the communication, we could have lost synchronization because none of us were getting your input. I've been thinking about this a lot, actually, that maybe there should be a way to not lose synchronization immediately when one player is not sending their inputs, that maybe it should just boot that one player. But I haven't found out a good like algorithm to determine that. Oh, synchronization lost! What? Man. Okay, we're doing a new build. We're doing a new build real quick. I'm just going to crank up the number of frames to something like huge. Let's, where do I got to do this? I mean, I will hack the add-on. This is the wrong way to do this for real, because rather than changing this in the add-on code, I'd have some other code in Retro Tank Party come in and change the max buffer size. I'm going to crank it up to 60. Let's see. Oh, and you know what? I should have looked in the logs because I should have some information about why synchronization was lost. Missing peers 3. Whoever peer 3 is, we lost synchronization because we weren't getting your input. So that's interesting. That's curious. You know, if you guys are running here, let me commit this. So I'll talk while we're waiting for it to build. Increase buffer size to 60. All right, that will start building. If you guys are running on Windows, there is like this thing. I don't use Windows super often because I run Linux. But there's a thing when you get like a new exe on your computer and you run it for the first time, it will sometimes like ask you for permission to do network things. And because this is using WebRTC, it could be doing some fancy stuff through like weird ports. And you might miss the like allow to do stuff dialog because it can sometimes like appear under the game or something. So anyway, if you're running Windows, keep an eye out for that and be sure to hit it if it asks you the question. So we're cranking up the frames. If this still doesn't work, I think what we should try to do is not have everyone join, because it definitely seems like it's one particular player, or at least like in the last run. I can scroll up and see if the first run was also that way. Where did we lose synchronization this time? So this one was frame 3. Where was the previous one, though? Because we lost sync 2 times, right? I only see 1. Oh, we probably didn't restart. We probably... Okay, yeah. I was looking for a new application start. All right, well, let's try this again. We'll try this with the more frames. So if you go to the same pipelines page, refresh, you should have a new pipeline at the top with the message increase buffer size to 60. Grab the new build. I'll grab my Linux build here, get it going. I'll give you guys a match ID in a moment. I'd also be curious, the people who joined before, if let me know what platform you're using. If you are using Windows or Linux or Mac OS, I'd just be curious. Definitely like multi-platform stuff, like the more platforms you have involved is the more potential for weird synchronization issues due to floating point value differences. All right, I hope that's the right build. When I downloaded that, did I replace the old file? Looks like I did. Okay. This would be so cool if this is just working in some fashion today. If even like I was saying before, even if we get the position synchronizing, oop, I didn't want to do that. No. Then there's still like a ton of work to get everything else working, like with shooting and the power-ups and the different game modes and all that stuff that would need to change for this new synchronization method. But wow, it'd be so cool if this if the positions were syncing right away. I'm like really legitimately excited about this synchronization method, and it's of course possible that we get it fully integrated and it sucks because of like too much rubber banding, but like I'm just super excited. It's so cool. Come on. Oh. All right, let's try it again, and just somebody sit it out. It looks like Ross offered to sit it out next time. Let's try with Tanks a lot and Andy K, and see if having Ross not be in it makes it work. I'll go look at the log messages real quick and see what we got here. It's still printing out tons of garbage. Probably there's something I could do to fix that. Okay, let me do Control S so it doesn't keep scrolling my window. Yeah, so whoever was Peer 2 this time, which actually should be sequential. If we pay attention to the window here, so it should be Peer 1, 2, 3. It should be. So Andy K is Peer 2, Tanks a lot is Peer 3. Let's give it a try. Nope. Who was it? Who is guilty? Skipping 15 ticks. Holy cow. Peer 4. Okay, I guess I'm wrong about the sequential thing. There shouldn't have been a Peer 4. We're missing Peer 4. All right. So who wants to sit it out this time? I don't know if okay, so Andy K is going to sit it out, so it looks like it's you and me, Ricardo. Sir Tanks a lot. Let me get this match ID in here. Where are you, Ricardo? How far away are you? Actually, being far away kind of makes you the best to test, because I want this to work with people far away. But I would like also to see it working too. So if it doesn't work, then we'll try with you out of it. Oh, no. Looks like it was Ricardo dropping on this one for sure. Whoa. Look at that round trip time in the some thousands of milliseconds here. Ah, you're out in Germany. I definitely would like to have this work with people who are, you know, and in the UK. So both of you guys across the pond, as they say. Let's try, Ross, if you're still around, because I know you're in the same region as me. If we could try connecting and see how that works, and then maybe we could try with Andy K, because we also don't know if his distance was too bad or not. I'm really surprised at those round trip times, guys. Like, this was crazy. Here, let me get a match ID out, and then we'll see. But like, scrolling up to those round trip times, and it's just gonna run me away. I don't want to pause my terminal again, because actually, after I did it the first time, I don't know if that also pauses my app by pausing the terminal output. Control S and Control Q to pause and unpause the terminal. But they were huge. They were huge round trip times. So Ross, if you're still around, jump in. There we go. Let's see what happens. Ah, synchronization loss. Okay, so something is not as it should be. Wow. So it works locally. And let me close this all the way so I can see the terminal output. So what did we get? We got sync lost because incomplete input from, who are these other peers? 3 and 4. I wonder if it's like not removing the old peers. I wonder if we were just doomed because I didn't restart the app, or did I restart the app? Let's try this again. Let's try this again. So the app is completely closed. Completely closed. I'm opening it up. And I opened it up down there. Let's open it up. Ah, wrong thing. Come on, Retro Tank Party. This Retro Tank Party. That other one. Whatever. Okay. Completely closed it. Completely opening it. I'm going to make a new private match. Let's try it. How about just Ross, if you're around again, let's try it just with us. And if this comes back with like a weird peer number, again, then we know like there's something screwed up in my peer adding and removing code. I can go take a look at that, and then maybe we could try a bigger match again. Because yeah, if it thinks there's a peer connected that's not actually connected, oh, or maybe Andy K. All right, Andy K, let's try it. Just you and me. Let's do it. See what we get. Oh, we didn't lose synchronization. Hey! Oh, Ross was in briefly? Whoa, I'm getting some serious rubber banding. Andy K, drive in some circles or something so I can see what that looks like. Wow, that looks weird. I wish I could see on your end what you're doing to make it look like that. Let's crash into each other a bit so that we can see. How are you driving to make it look like that? Can you just drive like straight? What is making it hop? That is wacky. Let me go look in the terminal to see if it's doing a lot of rollback. I'm not seeing a lot of state problems though. I guess it's going by really fast. Let me turn on the overlay here. Oh, we are getting state mismatches. We're getting state mismatches galore. Holy cow. How many ticks of rollback? Wow, this is 4 ticks, 3 ticks. So 4 and 3 ticks isn't that many ticks. Yeah. Andy, I don't know how you were driving to make it hop like that. Are you just trying to drive in a straight line, or like what are you doing that makes it go wacky? Or are you just driving straight? If you are just driving straight, that's making it go wonky like that, yeah, that's definitely some bug somewhere we gotta fix. It's probably with the input prediction, basing it on the input vector. You know, oh, hey, Thomas. It's awesome to have you back. I did end up, the thing we were talking about with the animation player, the seek versus advance, I did sort of come to an answer on that question. I can show you if you didn't see it earlier, if you weren't on the stream before. So Andy K says he was driving in circles, making it flop around like that. That is so weird. Something is clearly wrong. Something is clearly wrong with the input prediction. I wonder if I can reproduce that though locally with with just like adding some delay, because our RTT is actually relatively low. I mean, for you being in Europe, 150 milliseconds, like that's something we should be able to deal with. So there's clearly a bug somewhere. There's a bug that needs fixing. 160 ping. Yep, that's 10 frames. So the rollback that we're getting hasn't been at 10 frames because occasionally it will be predicting correctly. So it only will roll back to the point where its prediction was wrong. And so it could have been like predicting you going this way, but then 6 frames back you change direction, so it's only rolling back 6 frames. And we were only seeing like 4 or 5 frames, which is also probably because of the input delay. So we have that 2 frames of input delay that give us a little extra room. But yeah, I'm suspecting that the problem is with the way that I'm doing the input here, that it's sending this input vector rather than the actual like input values. And I think if I were to send the input values and base a prediction off of the input values, that it would not be as insane. So how much time do we have? We have no time. What? 12:01. I was gonna say I could try and sneak in changing the way the prediction is done. Let me try. We'll see how fast I can do it. I can go over time a little bit, right? That's fine. That's cool. All right. So there's 2 parts to this vector. Let's see how this is used. So left and right, that's the turning, and the up and down. Actually, why isn't this fine? Because a vector is just 2 numbers. Maybe because we're normalizing it? Maybe the fact that we're normalizing it is making it all wacky? But I feel like I could break this down to 2 numbers, not normalized, and that should be fine. Let's say we'll say var turning. We'll grab this one. And we'll say movement. I don't know, I just have to give things random names. And get rid of this for now. And we'll do if turning doesn't equal 0, then input. Wait. I'm in the wrong project. I'm like modifying code in the wrong project. Guys. Sorry. Moving too fast here. Players. Or no, tank in this one. Okay. So let's look at this. Okay. All this adjustment and minimum maximum stuff, like that's gotta be why this is weird. Can I write this code in a couple minutes? Oh, Andy K's got to roll anyway. You know what? I think I'm just gonna call it. Let's just stop for today. Let me look at chat really quick. Yeah. Oh yeah, I wasn't even paying attention to the rotation of the turret. Thomas says, in the rollback stuff I've seen, they set the number of frames based on latency of the connection. Yeah, we could adjust the number of frame delay, but depending on the latency, that's something we could totally do. Andy K's got to roll. Oh, it looks like Thomas has got to go too. Well, we got somewhere, guys, and it was hilarious. So that's something. Thanks again for hanging out. Thanks so much for watching. And I'll be hacking on this more through the week. I will probably post some stuff to Twitter or to YouTube or something about the progress, because this is so much fun. And definitely next week, next Friday, for the next stream, we can do some more testing. I'm kind of disappointed that the connection to Ricardo out in Germany was so poor, but because I want international connections to work. They work now. I mean, I've done lots of games of Retro Tank Party with people on different continents before. But yeah, this is exciting. I'm excited to see where this goes next, and can't wait to share it with you guys. catch you next week. Bye-bye.